Hi, so today we're going to be solving the CIE Mathematics 9709 February-March 2025 paper 12. Question number 1. A curve has the equation y equals 5 plus 3x minus 2x squared, and a straight line has equation y equals kx plus 13, where k is a constant. Find the set of values of k for which the curve and the line do not meet. So when two lines do not meet, that means b squared minus 4ac is smaller than 0. And it does say that it's a set of values, so it's going to be a range. The first thing I'm going to do is for the curve, I'm going to rearrange it so that we have negative 2x squared first, and then 3x, and then 5. It's just easier to visualize quadratics that way. And then the second equation is y equals kx plus 13. Because we have two y's and each y is equal to y, we can equate the two equations. So negative 2x squared plus 3x plus 5 equals kx plus 13. Then we can move the numbers and coefficients around. So negative 2x squared plus 3 minus kx plus 5 minus 13, which is minus 8, equals 0. Now we can actually use b squared minus 4ac, but I would like to get rid of the negative here, so I'm just going to move everything to the right hand side. So we'll end up with 2x squared, minus 3 minus kx plus 8 equals 0. And then we have basically 2x squared plus k minus 3x plus 8 if we multiply the bracket by minus 1, because there's a negative sign right here. And now we can use our b squared minus 4ac is less than 0. So our a is 2, k minus 3 is b, and 8 is c. So it's actually k minus 3 squared minus 4 times 2 times 8 is less than 0. If we multiply this all out, we get k squared minus 6k plus 9 minus 4 times 2 is 8 times 8 is 64 is less than 0. In other words, k squared minus 6k minus 55 is less than 0. And if we factorize that, k plus 5 times k minus 11 is less than 0. Therefore, our critical values are k equals negative 5 and k equals 11. If we draw out this graph for k squared minus 6k minus 55, you will find that it is like this, and there's going to be, it'll intersect with the x-axis at negative 5 and 11. As you can see, everything that lies below the x-axis is below 0, so because it's obviously down here. So k is within this range, therefore k is all of what is greater than our negative 5 and less than our 11. Question number 2. The diagram shows the curve with the equation y equals 2x squared minus 5 over x plus 3. The curve crosses the x-axis at the point P, which it has the following coordinates, so 1, 0, and M is a minimum point. Find the gradient of the curve at P. To find the gradient of any point on a curve, you have to find the derivative. So y, if I just rewrite it down here, 5 over x plus 3, this is actually equal to 2x squared minus 5x to the power negative 1 plus 3 to make things a lot easier. dy over dx, which is the derivative, is equal to 2 times 3, which is 4x. And obviously minus 1 from the power. And then minus 5 times minus 1 is plus 5. And x minus 1 equals minus 2. And 3 is just a number, so it's not included. Then we have to substitute for dy dx at the coordinate x equals 1, because that is our coordinates at P. We will get 4 times 1 plus 5 times 1 to the power negative 2, which equals 9. Then it says, find the coordinates of M. Give each coordinate correct to 3 significant figures. Okay, so M is a minimum point. Any minimum or maximum point is when dy dx equals 0. And that is obviously 2x squared plus 5. Oh, sorry. That is 4x plus 5 over x squared. If we multiply by x squared, we are left with 4x cubed plus 5 equals 0. So 4x cubed equals negative 5, x cubed equals negative 5 over 4, x equals the cube root of negative 5 over 4. And if we type that into our calculator, we will get negative 1.08 to 3 significant figures. And to find the y coordinates, we have to substitute that into the original equation. So if we do 2 times negative 1.08, or perhaps let's do 0.077 just so we're accurate, squared minus 5 over negative 1.077 plus 3, we are given the y coordinate to be 9.96 to 3 significant figures. So our coordinates are x equals negative 1.08 and y is 9.96. Question number 3, find the complete expansion of this. So this is in the form a plus b to the power n. So this is going to be a to the power n plus, it's going to be then, so it's to the power 4 to the power 1, and it's going to be a to the power 3b plus 4, 2, and then a to the power 2, b to the power 2, plus 4, 3, a to the power, just a, and then b to the power 3, then b to the power 4. Okay, so that if we just put that out, it's going to be equal to 2x to the power 4 plus 4 2x to the power 3, negative 3 over x, because this is our a, this is our b, without forgetting the negative sign. Sorry, and then plus 6 2x to the power 2, negative 3x to the power 2, plus 4 2x to the power, and then negative 3 over x to the power 3, plus minus 3 over x to the power 4. Okay, and if we multiply these all out, or expand them, we get 16x to the power 4 minus 96x squared, plus 216 minus 216x to the power negative 2, plus 81x to the power negative 4. Then it asks us to determine the coefficient of x squared in the following expansion. So because there's x on the denominator here, there is going to be some cancelling out. And because there's an x squared here, to get an x squared, we need either two scenarios. Either the x squared multiplies with a number, or this 5 multiplies with an x squared from this expansion. So if we look up here, the only number we have is 216. And if we look up here, the only x squared coefficient we have is minus 96. So our x squared coefficient is going to be our x squared from here, multiplying with 216. So there's a coefficient of 1 here, plus our 5, this is difficult to highlight, but our 5 multiplying with our coefficient of x squared, which is negative 96. And if we add them up, we'll end up with negative 264. Question number 4. The diagram shows a triangle OAB. OA equals OB, which is 10 centimeters. 10 centimeters. AOB is of an angle 0.8 radians. Points C and D on OA and OB respectively are such that the arc CD is part of a circle with the center O and radius 6 centimeters. The shaded region is bounded by the arc CD and the line segments CA, AB, and BD. Find the perimeter of the shaded region. So the perimeter is going to equal AC plus CD plus DB plus AB, okay? So we already know that AC equals DB, which equals 4. So we already have 2 sides, but we don't have CD. Now CD is the arc length, so it's equal to the angle, which is 0.8 in radians, times the radius, which is 6 centimeters. So 0.8 times 6 is equal to 4.8 centimeters. Now for side AB, we have 2 sides and an angle, so we actually can use our cosine rule, and that is AB squared is equal to 10 squared, the sides, plus 10 squared minus 2 times 10 times 10 times our angle cosine 0.8. This is from the formula A squared equals B squared plus C squared minus 2BC cosine A, by the way. Now, this will give us if we type that into the calculator, we get 100 minus 2 times 100 cosine 0.8. Make sure your calculator is in radians, and we get 60.659. We must square root it. So AB equals square root our answer right here, which equals 7.788. Therefore, we have sides AB, CD, AC, and DB. If we add up 4 plus 4 plus 4.8 plus 7.788, we will get 20.58. To 3 significant figures, we'll get 20.6. That is centimeters squared. Then it asks us to find the area of our shaded region. Now what we can do is, because this is a triangle, to find the area, we can find the whole triangle and subtract it from the sector. Okay? Now, to find the area of the triangle, 0.8, 10, 10, we can use half AB sine C. So, half AB sine C equals half 10 times 10, so 10 squared times sine 0.8. If we type that into our calculator, we will get an answer of around 35.868. And then our sector right here has an area of half r squared theta in radians, which equals to half times 6 squared times 0.8, because the radius on this is 6. If we type that into our calculator, we get 14.4. Now if we subtract 35.868 and subtract 14.4 from that number, we should end up with 21.468, and that is 21.5 centimeters squared to the 3 significant figures. By the way, this isn't centimeters squared because this is the perimeter, that's just centimeters, my bad. Question number 5. An arithmetic progression has the first term 5, common difference 6. For this progression, find the sum of all the terms that lie between 150 and 400. So it's arithmetic, and our first term, which is A, equals 5. Our common difference, which is D, equals 6. And we know that Okay, one sec. Our UN, so our nth term equals A plus N minus 1 times D. Okay, so in other words, UN, our nth term equals 5 plus whatever number term it is times 6. Okay. So one number, 5 plus n minus 1 times 6 equals 150, because we know this is a term in the sequence, and one other number equals 400, because that is also a term in the sequence. If we expand these, so we can do, for the first one we can do 5 plus 6n minus 6 equals 150. 5 plus 6n minus 6 equals 400. Therefore, n equals, so 6n equals 5 minus 6 is minus 1, 151. 6n equals 401. N equals 151 over 6. N equals 401 over 6. Therefore, 150 is our 25th term, and our 400 is our 67th term. Now it wants to find the sum between these two, so we're not going to include 150 and 400. So our sum is going to be our S66 minus our S26. So our first term is going to be our 26th term, so from here, 5 plus 26 minus 1 times 6 equals 155. And then our last term is our 66th term, so 5 plus 66 minus 1 times 6 equals 395. N is the number of terms, so 66 minus 26 terms, which is equal to 41. And then if we plug that into our sum formula, which is n over 2 times a plus l, gives us 41 over 2 times a, which is 155, plus 395, which gives us 11,275. Question number 6. The diagram shows a circle C, radius r, where x is greater than 0 and y is greater than 0 for all points on C. So basically C lies in the first quadrant. The least distance between any point on C and the x-axis is 8 units. So I think the closest C can be to the x-axis is this point, that is 8 units. And the least distance between any point on C and the y-axis is 5 units. So this point approximately is 5 units. State the coordinates of the center of the circle in terms of r. So our x-axis, or x-coordinate, is going to be 5 plus r. So r plus 5. And there's r here as well. So to get to the y-coordinate of things, it's going to be r plus 8. Then it asks us to give the distance between the origin and the center of the circle. It says that the distance between the origin and the center of the circle is 15 units. Find the value of r. So essentially this is 15 units, okay? Ooh, so what that forms is actually a right angle triangle if we look at that. R plus 8 is here. R plus 5 is here. R plus 8 is here, and this is equal to 15. And therefore, since it's a right angle triangle, we can use the Pythagorean theorem, where a squared plus b squared equals c squared. So r plus 5 squared plus r plus 8 squared equals 15 squared. In other words, r squared plus 10r plus 25 plus r squared plus 16r plus 64 equals 15 squared, which is 225. This means 2r squared, if we add up the values, plus 26r plus 25 plus 64 minus 225 equals minus 136 equals 0. So then what we can do is, using our calculators, we can solve for the quadratic, and we get r minus 4 times r plus 17 equals 0. In other words, r equals 4 or r equals negative 17. We know for a fact that r does not equal negative 17 because distances can't be negative, they're scalar, so r must equal 4. Then it says the point on the circle furthest from the origin is denoted by p. Find the gradient of the tangent to the circle at p. So we can say, let me just move out the way, that right here is p. And it wants us to find the gradient of the tangent. The gradient of the tangent would be right here. So to find the gradient of the tangent, what we could do is we can find the gradient of OP and then just do the reciprocal of that. The gradient of OP is equal to rise over run, which is, so our rise is r plus 8 over our run, which is r plus 5. If we substitute our r from before, which is 4, we will get 4 plus 8, which is 12, over 4 plus 5, which is 9, which is equal to 4 over 3. Therefore, m for the tangent is going to be the negative reciprocal, which is negative 3 over 4. Question number 7, part A. Show that 3 tan squared theta plus 5 sin squared theta is equivalent to the following. So if we take a look, there are no tans on the right hand side, so we're just going to turn that into a, what I'm going to do is, I know for a fact that 1 plus tan squared theta equals sec squared theta. Okay? And I know that sec squared theta is equal to 1 over cosine squared theta. I also know that cosine squared theta equals 1 minus sine squared theta, so I can then convert that at the end. So 3 tan squared theta plus 5 sine squared theta equals 3. So tan squared theta equals 3 sec squared theta minus 1 plus 5 sine squared theta, which equals 3, 1 over cosine squared theta minus 1 plus 5 sine squared theta, which equals 3, 1, 1 minus sine squared theta minus 1 plus 5 sine squared theta. Gonna try and make this into a whole fraction. So we're going to have to do 1 minus 1 times 1 minus sine squared theta over 1 minus sine squared theta plus 5 sine squared theta, which equals 3. 1 minus 1 is 0 plus sine squared theta over 1 minus sine squared theta plus 5 sine squared theta. Going to try and make this a whole fraction as well. So this can go here, actually, 3 up here. And we just have to do 3 sine squared theta plus 5 sine squared theta times 1 minus sine squared theta over 1 minus sine squared theta, which equals 3 sine squared theta plus 5 sine squared theta minus 5 sine to the power 4 theta over our 1 minus sine squared theta. And you will end up with, if we add them together, 8 sine squared theta minus 5 sine to the power 4 theta over 1 minus sine squared to the power theta, and we have our answer right there. Now it says hence solve for the equation 3 tan squared theta plus 5 sine squared theta equals 9 for the following interval. As you can see, they've just taken this, so what we can do is take this to equal 9 instead. So we will end up with 8 sine squared theta minus 5 sine to the power 4 theta. 1 minus sine squared theta equals 9. So 8 sine squared theta minus 5 sine to the power 4 theta equals 9 times 1 minus sine squared theta. Again, I'm just going to expand that out. Equals 9 minus 9 sine squared theta. I'm going to get, what I can do is I can move this to the other side. So I will get 17 sine squared theta minus 5 sine 4 theta minus 9 equals 0. I should have moved that to the other hand side actually. So 5 sine to the power 4 theta minus 17 sine squared theta plus 9 equals 0. If you can't already recognize, this is actually quadratic. We could just make sine squared theta just be equal to x, so 5x squared minus 17x plus 9 equals 0. We can type that into our calculator, and really what we will get is x equals 17 plus minus the square root of 109 over 10. And that means, however, x can only equal 17 minus 109 over 10 because the positive version gives x to be 2.744, and that implies that sine squared theta is 2.744. However, sine squared theta is bounded by -1 and 1. So then we put sine squared theta equals 17 minus root 109 over 10. And then what we do is we take the square root of that once again. 109. Square root that, and we get sine. Since we're in degrees, we have to switch our calculator to degrees as well. So sine theta equals 0.8099. Theta equals sine minus 1, 0.8099, which is going to be equivalent to 54.1 degrees. However, we have to lie within this whole interval, so there is a second value. If we draw the cast diagram, see, one value, which is 54.1 degrees, will lie here, and the second value will lie here. That is equal to 180 degrees minus 54.1 degrees, which equals 125.9 degrees. This is all to 1 decimal place, and it's not quite done yet. We also have I believe, we have another one, because it's actually sine theta actually equals plus minus 0.8099. So for the positive values, we get 54.1 degrees and 125.9 degrees. And then for sine theta equals minus 0.8099, we will get another value. We will get theta equals minus 54.1 degrees. However, this does not lie within the range, but if we do add 360 degrees, it will end up with 234.1 degrees, which does lie within the range. So these are our three answers that lie within the interval. Something we should have noted down earlier is that since we square rooted, it is plus minus as well. Yeah. Question 8. A geometric progression is such that the second term is negative 120 and the sum to infinity is 160. Find the common ratio. So our common ratio is our R. Any term in a geometric sequence, so un equals ar to the power n minus 1. Our second term is going to be our ar, which equals to r negative 120. Our sum to infinity is equal to a over 1 minus r, which equals 160. Now we have two equations with both a and r in them. So if we just sort of mess around, we can find our a and r. So for the second equation, a equals 160 times 1 minus r. A equals 160 minus 160 r. Which way around do we want to do this? I can just do here a equals negative 120 over r. So negative 120 over r is equal to 160 minus 160r. Multiply everything by r. We will get a negative 120 equals 160r minus 160r squared. Move everything to the other side because it looks better that way. And then we get a quadratic function. We can simplify this to equal 4r squared minus 4r minus 3 equals 0. This is done simply by dividing by 40. So we just divided by 40 here. Therefore, it is more easier to factorize. Even then, I will use my calculator. I will end up with 2r minus 3 times 2r plus 1 equals 0. Therefore, r either equals 3 over 2 or r equals negative a half. However, r cannot equal 3 over 2. R must equal negative a half. The reason for this is because if we substitute for our a, if a equals negative 120 and we divide r by 3 over 2, we will end up with a being 80. And if we do 80 times 3 over 2 to get our second term, we will get a positive 120. Therefore, our r must be our negative a half. Part B. The first 9 terms of the progression are now removed. Find the sum to infinity of the remaining terms. So, we're going to have a new first term. Now, originally, our first term was, well, we didn't calculate it actually, but let's do that now. So, our r is negative a half. Our second term, so our AR equals, it was negative 120. Our A equals a negative 120 divide R. Our A equals negative 120 divide negative a half, which equals 240. Our new A is going to equal our 10th term because we've removed the first 9. That'll be equal to AR to the power 9, which is equal to 240 times our negative a half to the power 9, which is equal to negative 15 over 32. Now we can just plug that into our sum to infinity formula, which is A over 1 minus R, negative 15 over 32 over 1 minus negative half, which is equal to negative 5 over 16. Question 9. A curve is such that the second derivative is equal to that. It is given that the curve has a stationary point at these coordinates. Use the expression for the second derivative to determine whether the stationary point is a maximum or a minimum. So, our stationary point has an x coordinate of a half. Our second derivative at the x coordinate is equal to, so we're just going to substitute a half into the x. So a half of 4 minus 5, a half cubed equals 96 minus 40. This is equal to 56. 56 is greater than 0. If the second derivative is greater than 0, that means we have a minimum point. Then it says find the equation of the curve. So if we have a minimum at 1/2 and 9, therefore our dy dx, our first derivative, is equal to 0 at x equals 1/2. And when you substitute 1/2 into y, so y equals 9 when x equals 1/2. So we will have to do a bit of integration here. So I'm just going to rewrite our second derivative so that it's easier to integrate this. Okay, so 6 times x to the power negative 4 minus 5x to the power negative 3. Our dy dx is the integral of our second derivative. So it's going to equal, so it's going to be 6x, negative 4 plus 1 is negative 3, divide negative 3, minus 5x minus 3 plus 1 is minus 2, divide minus 2, which is equal to negative 2x to the power negative 3 plus 5 over 2x to the power negative 2 plus c on both of those, my bad. And we know that when x equals 1/2, this is equal to 0. So we're just going to substitute for 1/2, negative 2 times 1/2 to the power negative 3, 5 over 2 times 1/2 to the power negative 2 plus c equals 0. If we just expand those, I'll do the math. Negative 3, that's equal to negative 16. 5 over 2 times 1/2 to the power minus 2 plus 10 plus c equals 0. Therefore, c must equal 6. So we know that that is our dy dx. Our dy dx, again here, equals negative 2x to the power negative 3 plus 5 over 2x to the power negative 2 plus 6. Now, to find our equation for y, we are going to integrate once more. Got to include that in there earlier, my bad. So then what we're going to do is negative 2x, negative 2, divide negative 2, plus 5x, negative 1, divide negative 1, plus 6x plus c. Simplify things, that is equal to x to the power negative 2, minus 5 over 2x to the negative 1, plus 6x plus c. Like we said earlier, y equals 9 and x equals 1/2. So if we substitute for 1/2 and equate that to 9, let's do minus 5 over 2, 1/2 minus 1 plus 6, 1/2 plus c equals 9. I could do the math, but I'm not going to. C will end up equating to 7. Therefore, our y equals x to the power negative 2 minus 5 over 2 x to the power negative 1 plus 6x plus 7. Question 10. The diagram shows the curve with the following equation. For values of x such that 0 or such that x lies between the interval 0 and 7 inclusive, the tangent to the curve at the point P, which is the coordinate at the coordinate 7, 0, meets the y-axis at point Q. Region A is bound by the curve and the two axes. Region B is bounded by the curve, the line, the segment PQ, and the y-axis. Find the area of region A. So region A is just the curve and the axes. So it's between x equals 0 and x equals 7. So all I have to do is the definite integral 7, 0. First I'm going to find the integral of our curve for the area under the curve. So y dx equals, so it's going to equal 4 times 3x plus 4 times 3 over 2 times 2 over 3 minus 2x squared divide 2, which will end up being 1, minus 6x. And since it's definite, I'm going to put 7 up here and 0 down here. All we need to do is we need to substitute for 7 and 0. So, how am I going to do this? Okay, I'll just do it like this. 8 over 3, this is times 3, 7 plus 4, 3 over 2, minus 7 squared, minus 6 times 7, minus 8 over 3, same thing, but different numbers, plus 4 over 3 over 2, minus 0 squared, minus 6 times 0, which gives us 13. Part B asks us to find the area of region B. So I brought down the diagram. As you can see, part B is basically just a right angle triangle minus the curve. So to find the area, we're just going to do this minus that. We know that the curve is 13 units squared. All we have left is to find the area of the triangle. Now, what we can do is we can find half BH. That'll be the area of our right angle triangle. We know that OP is equal to 7 units. All we need to find is OQ. Now, what information do we have? We know that it crosses our x-axis at 7, 0. Okay, so at the start it does say that they're tangent to the curve at the point P, so that means P is on the curve, it's a tangent to it, and we can find the gradient of the line at point P on the curve. So, and it's the same throughout because it's a line. So if we find the derivative for the gradient, it's going to equal 4 times a half times 3 times 3x plus 4 to the power negative a half minus 2. Which is equivalent to 6 times 3x plus 4 power half minus a half minus 2. And we can find at point P what the gradient is, which is at x equals 7 equals 6, 3 to the power times 7 plus 4 to the power minus 2. And if we substitute that in, we end up with negative 4 over 5. And since P has the coordinate 7, 0, our equation is going to equal to y minus 0 is equal to minus 4 over 5 times x minus 7. Therefore, y equals minus 4 over 5x plus 28 over 5. If x is 0, y is 28 over 5. So the coordinates of Q must be 0, 28 over 5. And therefore, this region right here is 28 over 5. Our triangle area is equal to a half times 28 over 5 times 7, which is equal to 98 over 5. 98 over 5 minus our curved area, which is 13. Is equal to 33 over 5 units squared. Question number 11, functions f and g are defined for all real values of x by the following. So this is f of x, this is g of x, where c and k are constants that are positive. It is given that the inverse of g, 3k plus 1 equals c. Show that g f of x equals the following. So g f of x is just substituting f into g. For x. So 2 times 4x squared minus c plus k. Expand that to get 8x squared minus 2c plus k. As you can see, there is no c involved, so we're going to have to find out what c is equal to. It's given this inverse of g of x. So to find the inverse of g of x, what we're going to do is we're going to let g of x equal y, and then we're going to make x the subject. So y equals 2x plus k, y minus k equals 2x, x equals y minus k times a half. This, okay? So g minus 1 of x equals, so we're going to switch x and y back, equals a half times x minus k. Here they've substituted for 3k plus 1, so a half 3k plus 1 minus k equals c. So 3k plus 1 minus k, actually I can just do 2c equals 2k plus 1. I can just directly substitute that because we already have 2c on both sides. G f of x equals 8x squared minus 2k minus 1 plus k, which equals 8x squared minus k minus 1 as required. Part B, the curve with the equation y equals 8x squared minus k minus 1 is transformed to the curve with the equation y equals h of x by the following sequence of transformations. So 1, 2, 3. Find an expression of hx of x in terms of x and k. So the first transformation we've done is there's a translation of 2 and 3. So a translation of 2 means that any x is going to shift to the right by 2 units. Whenever we're dealing with x's, it does the opposite. So for y, we're going to end up with 8x minus, instead of plus 2, squared minus k minus 1. But then it says we also have a translation of 3 units, positive 3, so 3 units up. So whenever it's y, it's outside of the brackets. So we're actually going to end up with y equals 8x minus 2 squared minus k minus 1 plus 3 units, and that can be simplified to minus k plus 2. Okay, that's transformation number 1. The second transformation is stretching in the y direction by a scale factor of k. So everything is going to be multiplied by k. And here, the third transformation is a reflection on the x-axis. If we want to reflect on the x-axis, the whole of our y must be multiplied by negative 1. Therefore, we're going to end up multiplying by negative k for the whole of the equation. So we're going to end up with negative k h of x equals h of x equals negative k times 8x minus 2 squared minus k plus 2. Part C. The range of h is given by h of x is less than or equal to 15. Find the values of c and k. So c equals k plus a half. That is because I've derived this from this equation right here. And our h of x is here. So this is greater than or equal to, less than or equal to 15. We can take this minus k and multiply out the brackets. Eventually, we will get this multiplied by k and this part multiplied by k. So k squared minus 2k is less than 15. We're going to ignore this part because it doesn't really matter. We're not talking about x. We're only talking about k and c. So I can actually turn this into a quadratic by moving this to the other side. Less than or equal to 0, minus 2, minus 15. This factorizes into the following, which gives us the critical values of negative 3 and 5. K cannot equal negative 3 because it says at the start here that c and k are positive constants, so k must equal 5. If k equals 5, c equals 5 plus a half, which is equal to 11 over 2.